All right, so today we're doing vertical asymptotes of logarithmic functions. And whenever you have a logarithmic function, you're going to have a number b. That b is called the base, and that's just going to be a number. You're also going to have an a right here. That's just being multiplied by the log. And then you have a plus e that's hanging off to the side. And we call this the constant. But what we want to do today is we want to look at what's on the inside of the parentheses, this cx plus d. What we're going to do to find the vertical asymptotes is we're going to concentrate on this. We're going to set it equal to 0, like this, and then solve it for x. So I'm always taking what's in the parentheses and setting it equal to 0. Let's try this first one. I have an x right here, so I take it out, I set it equal to 0, and I'm done. There's nothing else that I have to do. X equals 0 is going to be the vertical asymptote. Let's look at the next one. I have 4 plus 3 times log base 3 of x minus 2. So what I'm going to do is I'm going to take what's inside the parentheses, set it on the outside, and set it equal to 0. This time I get x minus 2 equals 0, so if I add 2 to both sides, that'll get rid of that minus 2 on the left side. The 2's cancel out. I'm left with 0 plus 2, which is just going to be 2. So x equals 2 is going to be the vertical asymptote. All right, for number 3, we have a natural logarithm, but we're only going to be focused on what's inside the parentheses right here, the x plus 3. When I set that equal to 0, I solve for x by subtracting 3 from both sides. So when I do that, I'm going to be left with x equals negative 3. The 3's cancel on the left side, and x equals negative 3 is going to be our vertical asymptote. All right, the last one we're going to do is number 4. This one is log base 10 of 2x minus 7. So I take out what's in the parentheses. 2x minus 7 equals 0. And I need to solve this for x. The first thing I'm going to do is I'm going to get rid of the negative 7 by adding 7. When I do that, I get 2x is equal to 7. And then I'm going to divide both sides by 2. That gets rid of the 2's on the left side. And I'm left with x is equal to 7 over 2. I can't divide that, so I'm just going to leave it as a fraction. That's going to be my vertical asymptote. Okay, so let's check and see what these look like when you graph them. I'm going to graph the very last one, and I'm going to show that the vertical asymptote is going to be 7 over 2. All right, so we go on over to Desmos, and I want to graph y equals log base 10. If you want to get the log, you have to go to the keyboard at the bottom and bring up the functions menu. You're going to choose the log base a. Of course, we can change that base to anything that we want. In this case, we got to have a 10. And inside the parentheses, we had 2x minus 7. So inside, I'm going to write 2x minus 7. Now the graph is going to show up on the screen. And where is the vertical asymptote? Well, we figured out that the vertical asymptote was at 7 over 2, or x equals 7 over 2. So that's what we're going to graph. X equals 7 over 2. And that's going to be that vertical asymptote. Whenever you have asymptotes, I like to make them dotted lines. So that way they won't be mistaken for anything else. What you'll notice is the cool thing about this graph is that it starts to display asymptotic action when it gets closer and closer to 3.5. And that's just that 7 over 2. But the graph never intersects this line. It just gets closer and closer. but they never actually cross. And that is vertical asymptotes.